Well, on today's lecture, we're going to learn how to create a graphical user interface by means of the Matlab guide. Guide stands for Graphical User Interface Development Environment. This will introduce all the needed concepts in order to supervise our system. You will see that our final application will be the mobile robot in the lab, the real mobile robot in the lab, to go from one starting node to one destination or target node by means of the minimum cost path in order to do some task. For example, here we will suppose that here we have the raw material, and here is the node where this raw material must be delivered. Well, what about this final item of our course? Well, the integration of elements is as follows. Well, first of all, we have studied discrete event system. You remember, this was the first item in this course, right? We used the SIM events toolbox within the Matlab environment, within Simulink, right? In order to simulate these discrete event system models, right? Well, so the main idea for the integration of elements is the following. We have the customers in here, right? These customers, they are ordering us some products to be delivered, right? So they expect some specific delivering time or delivering date, right? As you can see here, this delivering date, this expected delivering time, enters to the system as the set point for our feedback system, right? As you can see here, this is the classical feedback representation. It's a block diagram that shows us the direct chain, right? And the feedback chain, as you can see here. So it's a feedback loop. So what are we doing with this expected delivering date? We are comparing this expected date with the estimated delivering date. And this estimated delivering date will be the result of a statistical analysis on the simulation results of the discrete event system simulation, right? So the main idea in this closed loop diagram is that when we have an expected delivering date, we do the production planning. We are sorting the orders, right? According to some criteria. No product change, the same customer, the senior customer being served first. I don't know, but we will use the int limproc.m, you remember, the optimization algorithms that allows us to sort the orders to be produced, right? When we have order number 1, order number 2, and so on, then we introduce these orders to the discrete event system simulation, to the SIM events. We run this model several times in order to change the probability effects on this system, right? On this model. Then we get the simulation results. With these simulation results, we do the histogram, remember, and we can fit the probability density function that fits the best to our simulation results. So this is the statistical analysis. This statistical analysis will result in an estimated delivering date that will be compared, as you can see here, with the expected delivering date. If we have an error in here, we can change the production planning criteria in order to change the sorting of orders. Well, this error in here should be 0. That means that the expected delivering date will be exactly the same as the estimated delivering date coming from the discrete event system simulation. But if this error is not zero, but it means that the expected delivering date is longer than the estimated delivering date, it's okay for us, right? Because it means that the customers will be delivered on time. Well, at the end, will be delivered in time because this estimated time is smaller than this expected deliver time quantity. That's the main idea of this control loop. At the end, it's like a feedback control loop, right? But if this error is negative, it means that it will take more time to do the production process according to these sorted orders in comparison to the expected delivering date of our customers. So we need to rearrange the production planning in order to change the sorting of these orders, in order to change the simulation results, in order to shorten the estimated delivering date. That's the main idea. But we can have a problem also if this error is so high, not negative, it's positive, but a high value. It means that we can produce so fast. So the consequence of that can be that we have more resources than we need, right? Or maybe that we can afford more customers, right? So the general idea is that this error is is a positive thing, is to keep this error close to zero. That's the main idea. The same as in a classical feedback control loop, to keep this error equal to zero, right? If it's negative, it's a bad thing. Why? Because the system takes more time than expected, right? But if this number is so high, it means obviously it's a good thing because we can produce so fast in comparison to the expected time, right? But this can bring, for example, a conclusion that means that we have more resources than we need, right? So the main thing that you must keep in mind is that this error should be zero, right? So, well, this integration of elements will start with this lecture, with today's lecture. Our focus will be not to do this with a sim event simulation, but we will do this for real. So we will use a mobile robot in our lab. That's why next week we will have an in-class lab session, right? Because we are not going to use a sim events model. You know a lot about this, right? But we will do this for real in the lab. Well, the real application is the one that you have here in this slide. We have a ground mobile robot. It's like this. As you can see here, this mobile robot has a webcam, right? This webcam takes photographs about the environment, about this grid on the floor, right? And these photographs are sent, these pictures are sent to the main computer, to the remote computer. So you will have a computer, a desktop computer, that will receive these photographs, these pictures, right? So according to some procedure, some image processing procedure, these pictures will be translated into a distance to the line to follow. As you can see here, we have a grid because this robot will move along this grid, right? So these pictures, when they are processed by the remote computer, will tell us how how far is the mobile robot to the line to follow, and how bad, how wrong is the angle, because the angle should be zero, right? So the robot will move all along these lines, not this way, not this way, right? In order to supervise all the elements in this process, we will have a graphical user interface, as you can see here. Here in this section, in this left section, you have a representation of the 4 multiplied by 4, 16 nodes in this grid, as you can see here, right? The grid on the floor. So will be node number 1, node number 2, 3, and so on. So we have 1, 2, 3, 4 till 16, right? So the aim of today's lecture is to start with the guide, the Matlab guide, the graphical user interface, how to build a graphical user interface in order to monitor the position and the orientation of the mobile robot all along its travel on the floor, on the laboratory floor, right? That's the idea. So afterwards, I will explain this graphical user interface in detail. So it's not easy, but I will go step by step, right? But the main idea is that here you have the starting node, here you have the target node, right? This is the initial orientation of the robot, and here you have the path planning algorithm. You can choose between the greedy, the Dijkstra, and the A star. Remember from the preceding section in this course. And here is the optimum cost path. So this is the shortest path, right? That's the list of waypoints from 2 to 6, then to 10, to 14, and so on, right? So this is the waypoints list. Then you will have a button in order to run the process, right? Here you will have the information about the next node and the actual node, and you will see how the robot is moving all along this grid. But you will build this by your own, right? So that's the last objective of this course. Finally, obviously, a quit button in order to get out of this application, right? Well, this mobile robot application follows a state machine. That's very important in order to understand what's the robot doing on the laboratory floor, right? Well, as you can see here, we have state number 1, state number 2, state number 3, and state number 4. Well, the first state, at the beginning, the robot is at state number 1. So that's the first state to be followed, right? Well, the first state is about the odometry to turn. So suppose that we have the robot at a specific node, the source node, the start node, the beginning, right? Then, depending on if the robot must go to the right, to the left, or forward, right? Or maybe backward, the robot will need to turn a specific multiple of 90 degrees. That's because the front camera is taking photographs, right? So in order to follow strictly the line, you are expected to turn the robot in order to look always forward, in order to take pictures of the front line to be followed, right? To the vertical line to be followed. So that's the general idea. So that's why the robot needs to turn a multiple of 90 degrees at every node, right? So that's That's the objective of this first state, right? Obviously, it could be a turn of 0 degrees, 90 degrees, 180, minus 90, right? So it will depend. Uh, it's a very important thing is that you are not expected to build this state machine, right? The objective of this course is to build a graphical user interface in order to manage this, right? But you must not be worried about this. This is only an explanation on how the application, the mobile robot works, right? So you have nothing to do on that. This state machine will give you all the needed information in order to update this graphical user interface, right? Well, so how long it will take the odometry to turn? Well, while the odometry is in process, the system is kept in state number one, right? Well, once the odometry has finished, once the robot has turned 90 degrees, 180, whatever, then it goes to state number two. That's the line following. It's the main state, right? So this will just strictly follow the vertical line. So any disturbance, any mislead of the track, any disturbance that may happen in our system must be rejected in this state because we are strictly following the vertical line, right? So while no crossing is being captured in the picture, right? So the distance 2 is not a number. That means that, well, we have two distances. The horizontal distance, right? So this distance, the distance from the center of the robot to the line to follow, this will be called D1, right? While D2 is the vertical distance, D2 to the next crossing, right? So when D2 is not a number, so no crossing is being captured in the picture, you must, well, the robot is kept in this state, line following, right? Well, when the robot sees a crossing, so the system sees a crossing, then you change to state number three. That's obviously the same to follow the line, right? And then you will use the odometry until the crossing. So we know that the robot is here, right? And we must place the robot here, being centered at the crossing, right? So this will use the line the line odometry, right, until this crossing. The odometry means that we will measure by our sensors, right, our internal sensors, the robot's internal sensors, we will measure the distance to the crossing, right? So first of all, the picture will be processed by means of the remote personal computer, right? This personal computer will give the distance to the next crossing when it exists, right, in the picture. And then this distance will be considered in the odometry. Then the odometry will measure the distance run by the robot. And when this distance is equal to the original distance measured by the remote personal computer, then we will stay here in state number three. That's why here we will be kept here in state number three while the odometry is in progress, right? Once the odometry is finished, then we go back to state number three because we will be in the next node, just centered at the next node. So then it will depend if we have to turn 0 degrees, 90 degrees, 180, minus 90, and then the system Well, the loop goes on until the last waypoint is reached, right? Then what about state number 4? Well, when there is an obstacle here, when you have an obstacle, the robot stops, right? In order not to damage this obstacle, so the robot will stop, right? Well, an evolution of this state machine, as you can see here, when you reach state number 4, robot is stopped, and then you cannot go back to the original state, right? So, well, this is a basic application, but an evolution of this application should consider to go back to the calling state, right? When the obstacle disappears, right? But we will not consider this. Well, in order to start with graphical user interfaces, we just begin with the building of a simple graphical user interface by using the guide environment in Matlab, right? So we are going to build this user interface from the basement, right? So just type guide, and then it will open this guide quick start, right? I have some existing graphical user interface, so you can open any of them, right? But we're gonna create a blank graphical user interface. You have some like templates in here with user interface controls, access, and menus, model question dialogues, and so on, right? So I really exhort you, I really encourage you just to check these examples, right? But we're gonna build a graphical user interface from the basement, right? So, okay, and then a blank window appears, right? Just make it as big as you want, right? Or as small as you want. So we're gonna use, for example, this size, right? I'm gonna use this size because I will just build a simple user interface that will do, for example, the addition of two numbers, and it will show the result on third static text. You will see. Well, first of all, I will, for example, put a push button. Can you see here? You have all the candidate elements to put in here. You have, as you can see, a push button in here, a slide here, slider, a slide bar, radio button, a checkbox, static text in order to show some messages to the user, for example. Here, an edit text, as you can see here, a pop-up menu, right? Then here you have a list box, table, a toggle button, access, a panel in order to gather some specific elements in here, or a button group, right? Well, we're gonna show in this first video just the basic elements in this graphical user interface, right? Well, first of all, I'm gonna put a push button in here, and as you can see, you can change the size of the push button, for example, this, and if you want, you can change the color and the text to be shown. Just right click, and then you have the property inspector, or if you prefer, just double click on it, and you get access to the property inspector, right? So, well, first of all, here you have a lot of properties. That's all the properties for this push button, right? Well, the first property I want to be focused is the tag name, as you can see here. This will be the name to be referred at when you are coding some actions that involve this push button. So this will be, for example, calculate button. It's a more intuitive name, right, than push button 1. So this will be the tag name for this button, for this push button, right? So then if you close that, as you can see, when you select this push button in here, the tag name is shown at the bottom left part of the window, right? Calculate button. So go back to the property inspector. Remember, just double clicking or right clicking and then property inspector is absolutely the same. Well, the background color, I don't like this background color. For example, you can choose any color in here, right? For example, let's say this, right? You can change it. And as you can see here, the color has changed. You can put any, right? Any color here. But for example, this, right? And the push button changes, the background color changes, right? Fine. Additionally, you can, for example, tell in here the RGB combination, right? So in here, you can put an array with 3 numbers from 0 to 1, just telling the RGB color, right? For example, 111 should be red 1, green 1, blue 1. That means white. 000 means black, right? 100 is pure red, and so on, right? A combination, 0 point something, it's a mix level, level in the middle of this, of every red, green, and blue values, right? Well, so, well, nothing more to say according to that. Then, more things. For example, just here we can, for example, change. What about if we want to enable or not this button? For example, if we put off, this enable equal to off, then this button cannot be pressed by the user, right? Just check the following. I will run in order to show you what's the effect of that. I will save this, for example, in here, and it will be proposal 1 or operation, right? Then, as you can see here, this operation.m has been created, right? And this original file is operation.fig. So as I told you before, you have both files, the fig with the position and properties of all the elements, and the m file, operation.m, that has all the actions. We're going to go later on to this operation, right? Fine. So if you run this, it appears a window with the same size. Can you see here? The size is absolutely the same than I have specified before, right? And the push button cannot be pressed, right? Because it's not enabled, right? Well, so we can change this just by going to enable, right? Clicking here on. Then if you run this, then you can press the button. Obviously, there is no action being associated to this push button, right? Because we have not edited this operation.m, right? We will do it later on. But this now is enabled. You can click on it, right? That's the difference, right? So, well, let's go back here to the properties. I don't like the string push button. For example, calculate. Because the aim of my application will be to get 2 numbers and do some operation on them, right? So now we have the button in here. If you don't, the button is enabled, right? If you want to make this button not visible, just uncheck this, off, on, right? This way the button will be not visible. Now it's visible, right? And then, well, we will do some action connected with this calculate button. But before, we need the user to enter, in order to enter two numbers and then to do the addition of these two numbers, right? So, well, we will take a static text. Can you see here? And then just here, we will build this static text, and then we will configure this. Instead of static text, we will say just operator 1, right? So this will be operator 1. This is only an item in order to inform the user, right? In order to inform the user. This, it has no action connected to this, right? Then, now, here, we have the empty blank. This is an edit text, right? For the user to introduce some specific number, right? Then here, this edit text will be, for example, as you can see here, string edit text, right? You can tell, for example, 0. This will be the operator by default, right? 0. So then a 0 is shown right here. So when you run this, here we have a 0. And we can put any number, right? Just press enter. Any number in here. But now we have no action being associated to that, right? We have no specific action, right? So just we close that and let's check what can we do with this. Well, just put in the situation of the user, of this graphical user interface, and when you see here a 0, if it's fine for you, there is no need to edit this number. So what do I mean? That this number is a 0 only to be shown here to the user, but this 0 has no effect. It has absolutely no effect to the algorithm, right? So it's only for showing, no more. So then if you right click to this element, you have the callbacks, right? The callbacks. The callbacks are the actions being associated to this element, right? So, well, the default callback is this callback, right? But then you have different callbacks. The names just are telling us what are they doing. And an important callback, an important action is that create function. So when the graphical user interface creates this element, for example, we could assign the value for the first operator to be 0, right? So this would be so coherent with the 0 that appears here in the edit text, right? So create function in here, and when you click in here, it goes directly to the operation.m. These are the actions, right? These are the actions. So then here, this is a function called edit1 create function. As you can see, this is the tag name, right? This is the tag name, right? So if you want to change the tag name, just double click in here. Remember tag name, edit1, well, operator 1 input, right? Operator 1 input, right? This will be the tag name, right? Fine. So then, if you go to the create function, now one input, right? Well, now here it appears a warning, operator one input might be unused, right? Because it's being created but unused. Well, in order to assign a value, we can tell operator one equal to 0, right? This is a basic assignment, operator 1 equal to 0. But the problem is that this is a function, as you can see here. So operator 1 will have validity only within this function, right? So if operator 1 must be used by another function, for example, when you press this button, we will use operator 1, operator 2, and we will calculate the result, right? So, well, if we are using the value of this operator by means of another function, right, we need to do something with that because this value is only visible within this function. So, well, we have, for example, the Matlab workspace. We can use the Matlab workspace. Well, obviously, we can pass values between functions, right? But a basic focus on that problem could be to use the workspace environment. That is to save operator one in here, right? In the workspace environment. So we could do the following. We can use the function assign in. This function will assign some specific value to a variable in the Matlab base workspace. So the arguments will be where to save this variable, the name of the variable, operator 1, right? And finally, the value, 0, right? So this way, if you run this command, this will assign to variable operator 1 in the base workspace a value of 0, right? So that's the name of the variable, as you can see here between quotes, because it's a string, right? Then a character string, then this is a value, right? And this is a string telling the base workspace. The base workspace is this, right? Well, now we run this, and this element has been created, and you will see that here we have operator 1, it's a double, right? And its value is 0. You with me? Right. So what can we do with this edit text to change the value of operator number 1 according to the value that the user has introduced, right? So, well, just right click, callbacks, and we go to the callback action, right? Well, this callback action for an edit text, just it gives you some tips, some hints in here. Get this will return the contents as a text, right? Because at the end, the user is doing this input by means of the keyboard, right? And the keyboard is coded according to the ASCII code, you remember? So every letter, every key in your keyboard is assigned a code number, a binary code number according to the ASCII code, right? So that's why we get the string, and then we can we can change the type of this string into a double in order to have the number. Just, we can do this. For example, just copy this. This way, we will get the string, right? So we will get the ASCII code for the 0, right? For the number 1, for number 123, just the string. So all the character codes, right? That's the main idea. So this value can be assigned to a variable, for example, value, right? But this value is a string, not a number, so it cannot be operated, right? So then we will translate this string to a double, right? And we can do this way, string to double value, right? And we can assign this to operator number 1, right? But remember, this operator number one will be assigned only within this function, right? So if you want to get out this value from this function, right, you must use the assigning, remember, in order to assign this value to the workspace, or just pass this value as an output argument of this function, right? Just here as an output argument of this function, right? But we're gonna use the easy way, that is to share all the variables within the workspace, right? Obviously, you can do both this two-step procedure by means of a single procedure, string to double, get the string of the object, right? So we can do it once, just this, and we will get the double value. We will get the number, right? So this way we can, for example, do the following: assign in which workspace, the base workspace, right? Then which variable, operator number 1, remember, and which value, the string to double value, get the object, the string, right? Finally, I need to just close this round bracket, this parenthesis, and the semicolon to the end of this command, right? Well, now we will run this. As you can see here, we have a 0, right, in here. Then if we change 125, for example, we press the enter key, then the value has changed in the workspace environment, right? Well, just do the same thing for operator number 2. So just go here to the window, then just copy this, Control and C, Control and V, paste, right? Then here, sorry, here, it's operator number 2, right? The tag name, it's not important because it's only a static text, so nothing to do with that, right? And then here, it's not edit 2. This was operator 1 input, so now it will be operator, this tag name, operator 2 input, right? Fine. I will close this. And now, again, operator 2, just right-click, callbacks, the create function. Why? Because here I will assign in where workspace base, which variable, operator 2, which value, 0, right? So now I will run this. Both are created, and as you can see here, both, they have a value of 0. Nothing to do with the 125 as before, right? You remember? Fine. But no action being associated to this. If I type 125, enter, nothing to do, right? If here 654, enter, this is working. So now, again, we go back here, then right click, callbacks, callback, and then here, string to double. I will copy this, right? And remember, again, assign in where workspace base, then which variable, it will be operator number 2, and then which value, this value, round bracket, and n, right? Run this, remember, here we have operator 1, 1, 2, 3, whatever, operator 2, 1, 1, 1, right? So we have both operators, right? Well, now that we have both operators, it's time to calculate something. You with me? So let's first do the calculation, right? But before that, it's very important to show the result. So just, I will copy this, then here I will put result, right? Result, fine. So this will be the result, right? And then we can copy this, just paste this, because the result will be by default, the string will be in here 0, right? So at the beginning, it will be 0. You with me? But then this value will change depending on the calculation by using these two operators, right? Well, the tag name, I don't like this tag name, is text5, so just double click, go to the tag name, text5, it's not polite, so result, right? Or operation result, right? Fine. So then, well, now we're gonna assign some actions for this calculate, right? Just right click, callbacks, callback, right? Well, first of all, we need to get both operators from the workspace. You remember? So first of all, we have the opposite than the assign in operation, right? It's the eval-in operation. Eval-in. We will assess the following. In the base workspace, we will operator 1. That's the same, that's exactly the same. If you copy this, just paste this in here, and you get the result, right? So this eval-in base and this string is like to copy this string and paste it directly to the command window, right? That's the eval-in. So the result will be associated to, for example, operator 1, right? We could use operator 1, right? But in order to make the difference, op1, you can use any name you want, right? Because this name will be visible only within this function, right? Well, the same goes for operator number 2, right? Operator number 2 in here. You with me? So now the result of this copy and paste in here right? This result will be assigned to op1, and the result of this will be assigned to op2, right? This is only to copy and paste. Copy and paste. It's not, I'm not evaluating the value of this, right? That's the difference. I'm not getting this value, right? I'm just copying and pasting this string, and then when you, it's like if you press the return key, right? The enter key. So that's the idea. Then we have two operators. Then the result could be, for example, the addition, operator 1 plus operator 2, right? This is the addition. This is the result, right? But now this result is not shown in the graphical user interface. You with me? We have a warning here because it's unused. I'm doing absolutely nothing with this result. For example, we could assign this result in the vase environment, right? In the vase here, and to a variable called result, with the first being a capital letter, right? Result and result. You with me? Then we can check this, just run operator 1, 12, operator 2, 23. The addition, as you can see here, is 35, right? So then when you press the calculate, whoops, something, sorry, sign in, right? It's an assign in, right? Sorry, it's a sign in. Then I save this, and then when you press the calculate, you have the result in here, right? Result 35. You with me? Right? Fine. So now, well, I clear the comment window, nothing to do with this because, well, I have calculated as many times as you want. If you want whatever, calculate. As you can see, the numbers have changed, but nothing happens in here. You with me? I want this value in here to be shown as the result, right? So then, how can we do that? Just set, right? Which element we're going to use this property, handles, and then the tag name. What's the tag name? Remember that this tag name was operation result. So set handles operation result, right? The string field will be the number to string result, right? Then what am I doing in here? When you do number to string something, just copy this, paste in here. As you can see, result with the beginning capital R, right? Oops, sorry, it's this, right? Then ands is, as you can see here, a string. Can you see ands is a string of characters? Can you see here, right? 3 characters, right? So that's why here I'm doing the num to string, the result. Then I assign the string property for this operation result tag name. The handles is only to handle, right, all the tag names. So you can change any property of any tag name of any element in the diagram just by using handles dot something, right? That's the tip. Yes. So I will run this 1, 2, 3, 3, 2, 1, for example, calculate, and the result is assigned in here, right? Just not depending on the assignment on the workspace, right? It's assigned, yes, but we have no need to do that. We can just comment this, right? And the program is working perfectly. Calculate, right? Because you are not using the workspace at all. Fine. As I told you, you can change any property. For example, now if we have, for example, 0 in here, 0 in here, right? For example, we run this at the beginning, right? At the beginning is 0, 0, 0, right? So you can press the calculate button, but it's a stupid thing, right? Why? Just because operator 1 and operator 2 has not been introduced, right? So, for example, we can change the property of enable, right, to this element according to the input of these two operators, right? Well, just have a look at this. Let's go here, right? Well, I'm gonna change the property, this, remember the enable, into off. You with me? Now, if you run this, obviously you can introduce any number in here, but nothing to do on that, right? We can, for example, just disable this property inspector, right? Here, enable to be off, right? So then, if you run this, obviously, just you cannot enter operator number 2, but you can enter operator number 1, right? So my proposal is to enable this element when operator 1 has been introduced, then to enable this element once operator 2 has been introduced, right? So let's go to the callback of operator number 1 in here. You have the callback. Remember the assignment of operator number 1, right? Well, then you can set what handles that I want to make this so enabled, right? That's operator 2 input. You with me? So that's operator 2 input, right? Then enable, remember the property is enable, right? That's why here the property is enable, fine, and it will be on. So now it makes operator number 2 right in here. You with me? Fine. So now we can do the same thing, just copy, right? Copy and do the same thing in here. Just callback, right? And then here, handles, now not operator 2 input, but it's the button, remember? What's the name? Calculate button. So calculate button, right? You with me? Then this, operator 1, 12, operator 2, 24. Then I can calculate, and the result is 36, right? For example, the result should, for example, not be visible. So result, this, double click, visible, not visible, you with me? And then, because this is operation result, operation result, when I calculate, I will make operation result not enabled but visible, right? Then you run, no result in here. Can you see? 23, 12, right? I calculate, and the result is 35. We have a graphical user interface, but it's always doing the same thing. If I introduce a number in here, then a number in here, and then the operation is always the addition of these two numbers, right? So why not, if we add a pop-up menu in here, in order to choose, for example, between the addition, the subtraction, or the product, or the division with these two numbers, right? So we can use, for example, a pop-up menu just doing this. As you can see here, we have the string pop-up menu. Just choose the operation to do, right? Just choose the operation to do. Then here we have just choose the operation to do. If we run this, then here we have no values, right? We have no values because it's not configured yet. So we just go here, and then for the string, just click in here. Then it appears a new window with the first sentence in here, and then, for example, addition, subtract, product, division, right? Fine. So here we are. Now, with no actions yet, right? But we have this. We can choose addition, subtract, product, division, right? Well, for example, this should not be visible, right? Should not be, well, not visible or enabled. For example, enabled in here should be off at the beginning, right? This is pop-up menu 1, right? The tag name for this element is pop-up menu 1, right? So remember that the calculate was enabled here when you introduced operator number 2. So we can again go here, callbacks, this operator number 2, and remember the calculate button was enabled in here. I will cut this because I really don't like this, and I will go here to the callbacks, right? And once we have chosen the operation, the calculate button should be enabled, right? That's a good tip in order to run the graphical user interface properly. Fine. So now we gonna change that. Now this makes this enable. Now this should make the pop-up menu enable. Remember that it's pop-up menu 1. So we go back here, the callbacks, right? These are the callbacks, operator 2, and here is pop-up menu 1, right? Remember, this pop-up menu 1, right? So now we save this, we can run, then let's check, fine, and then this is not working. Why? pop-up menu 1. Sorry. Well, now this callback. Sorry, it's this. This is pop-up menu 1 enable on. Sorry. So now save. We run this 12 here, and then this is enabled. Now it's doing nothing, but once you have clicked to any option, the calculate button is working, right? But it's the addition, despite we have chosen another thing. So now let's check about the consequences of this, right? So let's go here to the callbacks, and then let's check the hints, right? Well, these are the contents. This gets the string. Let's check this, right? Because this returns pop-up menu contents as a cell array, this cell of strings, right? But this contents get object value returns the selected item from pop-up menu 1. So let's gonna check this here, right? Let's gonna check this. We will save, right? Now we're gonna go here again, this 12, then 1, whatever, and then here, remember, here we have this, the command window, and then when I choose, for example, addition, oops, we don't have any contents. Wait a minute. So we can use this to get the value, right? Let's get this value, and once we choose anything in here, right, we get the number of our choice. Subtract is 1, 2, 3. 3. Can you see here? Product is 4. 4. Division is 5, right? So this will be the operation to do, right? 2 will be the addition, 3 the difference, product, and division, right? So here we can assign in workspace base, then the name of the variable operation to do, right? Operation to do, and then the operation to do will be assigned this value, right? Then semicolon at the end. So now if we run this, the operation to do, if it's division, it will be operation to do number 5, right? So 2 to add, 3 to make the difference, 4 the product, and 5 the division. So now we go again here at the calculate, and then we're gonna have a look at the callback, right? So the callback is not the addition, right? It will depend on the operation to do. So operation, right? It will be to eval in what? in the workspace base variable operation to do, right? Then we will have the operation depending on your choice in the pop-up menu, right? So, well, now you can use if operation is equal to 2. This means the addition, right? So it's fine. Then else if operation is number 3, it will be the difference, right? Just copy here and here, it will be the difference, right? Just then I will copy this 2 more times in here, this, and then this, and finally end. This will be the division, this will be the product, right? And this will be 4 and 5, right? Then the result will be sent as a string, right? And if we want, we can assign it at the base workspace, right? So now we can run this. Let's choose the addition. So we calculate, it's the addition, as you can see here. Subtract is the difference, product is the product, and division is the division, right? So that's the way we can, for example, do different operations depending on your choice within a pop-up menu, right? So if you translate this to start node, target node, and then the algorithm to be used, you can use the source node, the origin node, the target node according to this algorithm, in order to give the user the resulting list of waypoints. So that's the list. That's the aim of my explanation, to get the list of waypoints by means of this introduction to graphical user interface by means of the guide environment.